Let's take a look at the help video for the homework, additive, multiplicative, equations, tables, and graphs. If we look at our input variable, starting with 4 and going to 7, 4 plus 3 is 7. Now we're going to go to the next x input and check and see if that's the same thing. 4 plus 3 is 7, 5 plus 3 is 8, and 6 plus 3 is 9. So this would be the output y is coming from x plus 3. So determine if each relationship is an additive relationship. 3 is being added to each x input. Just a little explanation. So here, 0, 0, nothing was added. Since nothing was added, then this is a multiplicative relationship. And then we have 2 times 4 is 8. And then 4 times 4 is 16. So we have 4 times x equals y. But then we have equation format, y equals 4 times x. Just a couple notes right there. The number 1 is additive, number 2 is not. Continuing on to number 3, have you draw a quick input-output table with x on the left, y on the right. So go ahead and draw that on your sheets of paper. If you want to label the top input and output, first we're going to go over here and look at x, and then we're going to look up at y. So the first point is 0, 1. Then we have 2, 4. And then we have 4, 7. What's the point of creating a table? The table will help us organize the data from the graph, and it will help us find what is happening with the rule. So if we look at the first x, how do you go from 0 to 1? By adding 1. So 0 to 1, so we know we have x plus 1. So if we come down here and then we do 2 plus 1, that equals 3. So we need something more to go from 2 to 4. And it's not just 2 plus 1. So this one, something else is actually happening. So one way to check what's happening to the x, you go up and over, you put the change in y over the change in x. How far up from one point to the other does the y go? 1, 2. And then how far over does the x change? 2. So the change between these two things, you're going to end up with 3.5, which simplifies to 1.5. So now let's check and see if that rule is true. What's 1.5 times 2? And what's 3 plus 1? 4. That one checks out. So what's 1.5 times 4? It's going to be 6, and then 6 plus 1? 7. So that one checks out as we go through the... Is this equation additive or multiplicative? It is both. It starts off with the coefficient 1.5 times x, and then it adds 1. So this is and multiplicative. Y is equal to 1.5 times x plus 1. Move into number 4. Create an input-output table with an X and a Y. And now take the ordered pairs from your graph. 1, 2, 3, 4, 7, 8. How do you go from X to Y when X is 1 and Y is 2? So we add 1 to X. 1 plus 1 is 2. So now we check it here. 3 plus 1 is 4. And then one more check. 7 plus 1 is 8. So the rule is X plus 1, not Y. And then the equation is y, the output, is equal to X plus 1. Is that additive or multiplicative? Additive only. Please label your graph X and Y just as a quick habit. We have our X and our Y, and then this is going to be independent, and the Y is dependent. So we start down here. The money in the bank account, the amount in the bank for X is starting with 20. And then 30, 40, and 50. 20, 30, 40, 50. So we start with the X value. We go up and out to the Y. So when X is 20, how much is in the account? Or let's see, how much can she spend? 30. When 30 is in the account, what's the total amount she can spend? 40. Input, output. Input, output. So what is happening each time when something is in the account? Plus $10, plus 10, plus 10. Now in this particular example, it started with 10, but we could have extended the graph all the way down to 0, but that says that your bank account is at 0, 10, or 20. So the rule is whatever's in the account, 10 is being added to it, and that equals your output. But then linear equation format, we have y equals x plus 10. Okay. Second part for this assignment is looking at the multiplicative relationship. Knowing our math facts of multiplying times 2 times something, 3 times something, 4 times something, I believe this is, well, this is not. This is adding. 2 plus 7 is 9. 3 plus 7 is 10. 4 plus 7 is 11. So just checking the pattern there. The other option would have been multiplying 2 times 4.5, but then that doesn't work for the next one. So this is additive. Looking at the 0, 0 point, when x is 0, y is 0, then that is multiplicative. 3 times 9 and 5 times 9. So this is multiplicative. Y equals x plus 7, and this would be y equals 9 times x. Now, if you wrote it like this, x times 9 equals y, that is also correct, but that is not our linear equation format. We're going to write it as y equals 9 times x. This is plus 5. 5 plus 5 is 10. And 7 plus 5 is 12. So this is not an additive. 5 times 2 is 10. 7 times 2 is 14. 9 times 2. So this one checks out as a multiplicative relationship. So it's multiplying. Every x input is multiplied by 2. So looking at the last one here, one-fourth is equal to 0.25. 2/4 is equal to 0.5. And 3/4 is equal to 0.75. So looking at the pattern in table 4, 1 divided by 4, 2 divided by 4, and 3 divided by 4 would give you the rule in the table from the input to the output. So you could do x divided by 4 equals y, but another way of saying divided by 4 is making it a fraction and multiplying. 1/4 x, 2/4 x, 3/4 x. So in fraction form, 1/4 times x will always give you your output of y. And the last example down below, it would be best to use a table for Todd and David. You have x and y. We can say this one is Todd, and then this one is David. Create an input-output table, and then compare, finding the rules within the table. So Todd has 1, 3, 2, 6, 3, 9. 1, 3, 2, 6, 3, 9. And David is 0, 9, 1, 10, 2, 11.